This is the first time we get to orbit Mercury. Out there at the forefront of our solar system lies Mercury, a small, uninhabited planet wrapped in a web of intrigue and mystery. At a mere glance, nothing seems significant about this planet. However, recent investigations by NASA have revealed some shocking revelations about Mercury that no one expected. Some of the mind-blowing discoveries, including data from the James Webb Telescope, have sparked controversy within the scientific community, with many hinting at the possibility of extraterrestrial species hiding on the planet. Amidst the chaotic revelations and bizarre conspiracy theories, a new plan is springing up within the scientific community. It is the master plan to strip Mercury of its mind-boggling masks and reveal its dark secrets once and for all. What mind-blowing secrets have scientists discovered about Mercury? And what revolutionary plans does the scientific community have for this mysterious galactic neighbor? Join us in this video as the Webb telescope finally found what NASA was hiding on Mercury all along. Our solar system is more than just an intrinsic body of planets swinging in a cosmic mirror. Around each of the 8 planets that make up this enigmatic ring system lies fascinating features of its own. Although planets like Jupiter and Mars may have taken the spotlight with their astonishing significance, one other interesting planetary body that seems to be lost in the crowd is Mercury. Mercury is the planet that lies at the very top of the list of planets in order of closeness to the Sun. Its distance from the Sun is a mere 58 million kilometers compared to Earth's 150 million kilometers. Mercury is also quite tiny compared to Earth, measuring only 3,000 m in diameter. Thanks to its tiny radius around the Sun, Mercury is the fastest planet to complete its revolution around the Sun at a whopping speed of 47 kilometers per second. The planet completes a full rotation in just 59 days. In other words, 1 year on Mercury is merely 88 days, or 3 months on Earth. Mercury's small size and immense speed are just a few of its fascinating features. From a distance on the cosmic map, it even looks like a habitable planet. The small planet has always been intriguing to the scientific community, but for some reason, it hasn't garnered attention like most of its cosmic neighbors. The first recorded observation of Mercury was in 265 BC. Early astronomers, like Zupus back in 39, also studied the planet. However, all the scientific community had in these early times were bits and pieces of data, as all of their research was conducted using substandard scientific equipment and ancient telescopes. It wasn't until the 1960s that real tangible data about Mercury came to light, thanks to the efforts of the National Aeronautical and Space Administration, NASA. A few years ago, NASA revealed the first real images of Mercury to the public. These larger-than-life photographs showed Mercury as a celestial embodiment of beauty and complexity, but it didn't come cheaply. In fact, despite years of planning and constructed effort to explore Mercury, scientists were only able to glance at it. The truth is that scientists have a hard time spying on Mercury like they do on other planets because of its proximity to the Sun. The Sun's unforgiving rays and bright light can damage optical instruments, like telescopes, when they gaze at Mercury for too long. As such, scientists can only glance at the tiny planet for a few minutes at a time to prevent damage to equipment. Even the James Webb Telescope cannot point toward the planet due to its closeness to the Sun. It's quite enigmatic how this relatively small nearby planet is harder to study than the farther planets, all because of the temperature and gravitational pull from the Sun. Sending a probe to Mercury is more like a suicide mission than a stellar mission. The probe must adapt to the temperature, atmosphere, and gravitational pull experienced there. Otherwise, it will waste away. It would shock you to know that Mercury blazes around the Sun at a whopping speed of 30 meters per second. This time-shattering speed makes it the fastest orbiting planet in our solar system. And just so you know, this also poses a difficulty for spacecraft that intend to survey the planet or land on its surface. So far, only two space missions have had Mercury as its target. The Mariner 10, launched on November 3, 1973, and the Messenger, launched on August 3, 2004. Both of these missions were the brainchild of NASA, and they are the primary sources of nearly all the information we have about Mercury today. The Mariner 10 spacecraft conducted 3 flybys, each unmasking the cracked-up, crater-ridden surface of Mercury and shining light on its magnetic field. In case you're wondering, this spacecraft was equipped with 2 telescopes, spectrometers, a magnetometer, spectrometer, and plasma analyzer. NASA intended to glean as much data as possible from Mariner 10's visit to Mercury. As luck would have it, the probe slowly found its way to the small, fast planet. As Mariner 10 approached Mercury, scientists were amazed to see the chaotic surface of Mercury. It was ridden with lots of craters and ridges, much like our moon. The images from Mariner were mind-blowing, as Mercury turned out to be nothing like what experts had ever anticipated. Aside from the rugged planetary surface, the spacecraft also detected a weak magnetic field and an unusually large core. In all, the Mariner took over 2,700 images of Mercury, giving scientists a rare and unparalleled view of the fascinating landscape. The second flyby of the Mariner was on September 21, 1974, during which it captured the southern polar region of the sensational planet. The last flyby of the Mariner 10 was in March 1975, after which it stopped transmitting signals to Earth. Later investigations revealed that the spacecraft had exhausted its supply of gas, and so was unable to make any more rounds. The magnificent work of the Mariner 10 was continued 30 years later, when NASA's Messenger took off to the not-distant planet. Unlike its predecessor, Messenger didn't just conduct a flyby, but also managed to orbit the planet. Thanks to this, scientists were able to gather more in-depth and interesting data about the planet. Armed with the interesting pictures of Mercury, NASA saw deeper data with this mission. This time, it wasn't just about pictures. The agency wanted to know more about the atmospheric conditions and chemical composition of the planet. NASA also had to study the planet's magnetic field as well as dig deep into its geologic history and planetary core. As you'd expect, the Messenger probe was loaded with all the necessary gadgets it would need for this groundbreaking mission. Interestingly, the probe made 3 orbits around Mercury, during which time it took about 200,000 photos of the planet. These pictures were unique because, unlike the Mariner mission, they featured both sides of the planet. During the Messenger mission, the probe managed to enter well into the planet's orbit, hovering at about 250 kilometers above the planet's surface. This proximity enabled the probe to take pictures of both the light and dark sides of Mercury. After digging deep into the images and comparing them with data from the spacecraft's instruments, NASA found out that our dear sister planet had unusually high concentrations of calcium and magnesium on its night side. Moreover, the magnetic field of the planet seems to be weirdly distorted, appearing to be stronger and more intense in the northern regions. This weird pattern of the magnetic field puzzled scientists for years, until deep research analysis was conducted to reveal the secret behind this anomaly. You see, Mercury's weird and unusual magnetic field is all due to how the planet formed at its core. Magnetic fields on planets are generated from the reactions that go on in their core. Take Earth as an example. The innermost parts of the Earth's core contain liquid iron, but towards the outer core, this iron changes to solid. The continuous or progressive solidification of liquid iron in the core is what causes a magnetic field. In other words, more and more solid iron is being formed in our planet's core every day. As liquid iron cools and crystallizes to form solid iron, it interacts with the surrounding liquid iron. As this happens, as the Earth spins around its axis, a form of convective current is created. In the end, powerful electric currents are generated that produce a massive magnetic field stretching out into space. This is the exact mode of operation for the Earth and how its magnetic field lines are generated. For Mercury, however, it's a different ball game. In fact, Mercury's mode of operation is so bizarre that it left scientists completely mind-boggled. In recent research led by Hua from the University of California, Los Angeles, it was discovered that iron turns from liquid to solid at the core's outer boundary. This is very different from that of Earth, where the conversion from liquid to solid takes place at the core's inner boundary. Hua had this to say: "We had figured out how the Earth works, and Mercury is another terrestrial rocky planet with a core, so we thought it would work the same way. But it's not working the same way. It's like a snowstorm in which the snow forms at the top of the cloud, the middle of the cloud, and the bottom of the cloud too. Our study of Mercury's magnetic field indicates iron is snowing throughout this fluid that is powering Mercury's magnetic field." Further research showed that Hua's research was consistent with data from NASA's Messenger mission. The mind-boggling revelation led scientists to believe that planets have more than one way of generating magnetic fields. Although the cores of Mercury and Earth contain similar constituents like sulfur and iron, certain disparities in these two planets can produce astonishing differences, as seen in their magnetic fields. However, the disparity between Earth and Mercury goes well beyond its magnetic field. You see, there are many differences that set Mercury apart from our home planet. One of the most notable is its lack of atmosphere. Unlike Earth, which has a thick, protective atmosphere that supports life, Mercury's atmosphere is extremely thin and composed mostly of oxygen, sodium, hydrogen, helium, and potassium. This tenuous atmosphere, known as an exosphere, is constantly being replenished by particles from the Sun and material ejected from Mercury's surface due to micrometeorite impacts. Additionally, Mercury's surface temperature varies dramatically. During the day, temperatures can soar to about 430 degrees Celsius, 800 degrees Fahrenheit, while at night, they can plummet to -180 degrees Celsius, -290 degrees Fahrenheit. This extreme temperature variation is due to the planet's lack of atmosphere to retain heat. Another fascinating aspect of Mercury is its geologic activity. Despite its small size, the planet shows signs of significant tectonic activity. The Messenger mission discovered long cliffs, or scarps, that indicate the planet's crust is shrinking as its core cools and contracts. These cliffs, some of which are hundreds of kilometers long and several kilometers high, are evidence of Mercury's dynamic geological past. Furthermore, Mercury's proximity to the Sun has resulted in a unique relationship with its star. The planet is subjected to intense solar radiation and solar winds, which have a profound impact on its surface and magnetic field.